recorder is on. And we'll go ahead and get started. That's not for this class, don't worry. All right. All right, the recorder is on, and I will pass the roll sheet first today, so this way we can get this out of the way. All right, are there any questions about the homework that was just due a few seconds ago? About a minute. Okay. Okay, no questions? Or, yeah, go ahead.
When you run tests, you're going to run tests with the divisor being 0?
No, the divisor is guaranteed to be at least 1.
Okay.
So you don't have to handle the special case of when it is 0.
Because I was trying to do that with the divisor being 0, and I was trying to create a string that would say undefined.
Okay.
But I didn't know strings, and so I just compensated for it.
You don't have, well, are you talking about in the GDB script, or are you talking about in your actual C++ code?
In the actual code, I accounted for the dividend.
In the actual code, you can make the assumption that that will not happen.
Okay.
Yeah. All right. So let me just go ahead and do my own homework assignment. Okay. I know many of you, did this, and you don't have a problem. But I'm going to do my own homework assignment anyway, and just kind of show you the process, that I go through to do a programming assignment like this one. Okay, and if you have any questions, when you are doing your own homework assignment, this would be a good time to bring it up. Okay, and I would try to even, integrate some of the questions that you have asked me. Some of you have asked me over the past 2 days or so. Okay, so I just want to emphasize, typical pitfalls that people can kind of get trapped into. Okay, all right. So the file is divide.tar.gz. I put it into the temp folder. That's not where you need to put it. Okay, you have to put it into your home folder in the Linux machine. But since I don't need to save it, I just put it here. Okay. So after you tar it, it will create a folder called divide, and we go to the divide. The source code is main.cpp, and that's where we will do all of the work that we have to do. Okay. Line 7 is a label start here, and line 15 is a label called check here. You do not want to remove those labels, okay? Because if you remove those labels, my script cannot work. I cannot grade your submission if those labels are gone. Your code has to fit between, okay? You can use as many lines as you want, okay? You can use any control structure that you want. You can use addition, subtraction, comparison. You cannot use multiplication. You cannot use division. So those 2 operators you cannot use, but everything else you can use. The restriction that I have already, well, not restriction so much, it's a condition. I already tell you that you can assume that divisor is greater than or equal to 1, which means you don't have to handle the special case of division by 0. Okay? You also guarantee that dividend is greater than or equal to 0, which means you don't have to deal with the case of a negative dividend, because in that case, there are several ways to handle that, but let's not even go there. Okay, we'll just say that the dividend is always going to be non-negative. All right. So how do we get started with this code here? The first thing I would do is I would think about, okay, let me do it by hand first. Okay. So I want to do it by hand and say, okay, how can I find out what is the quotient and what is the remainder of a division, but I cannot use actual division. Okay? So how would you do it? We talked about that last time. Remember the spreadsheet that we talked about last time? Okay? So if I want to show that in a text file, so I will just go ahead and open mousepad here. The way that I did, just manually, was something like this. Okay, so let's say we want to divide 25 by, 7. Okay, so 25 divided by 7, I have to basically find out how many 7s do we have in 25, and after that many 7s, what is the remainder? Okay, what is left after those 7s are accounted for? All right, so the first question is 25 greater than or equal to 7? Because if 25 is not greater than or equal to 7, then I'm done already. Okay, there's no more, I don't need to deal with the divisor anymore. 25 is greater than or equal to 7 is true, right? So what do? We say divisor, quotient, excuse me, quotient is now 1, okay? But I also have something else to do, because I have to say, oh, the next number, the next value that I have to consider is no longer 25. I have just taken care of 7 out of 25. So the next number or the next value I have to deal with is 18. So I have 18 basically as the remaining portion. So now I do the same thing with 18. 18 is greater than or equal to 7 is true. So quotient is now 2 because I have to increase it. There's another 7 in 25. And after I take care of the second 7, so now I have taken 2 7s out of 25. So I have 11 left. Okay, so 11 is remaining. And 11 itself is also greater than or equal to 7. So it is true. The quotient is now 3 because there are 3 7s in 25 up to this point. But what is remaining is only, let's see, 11 minus 5 is 4. So I have 4 remaining. And then the last one is asking, is 4 greater than or equal to 7? The answer is no, or it is false, and I'm done. Okay? So from this process, I would look at this and go like, well, the number of times I have to go through this, okay, depends a lot on what is my dividend and also what is my divisor. Okay, I do not know ahead of time how many times I have to do something like this. Whenever you have a situation like that, okay, you have something that seems to be repetitive and there's no fixed number of times that you can predetermine to do something like this, then you are looking at least a loop. Now, there are different types of loops in C. Okay, in C there are do loops, which are post-checking loops. There are pre-checking loops, which are basically the for loop and the while loops. At this point, I'm not even concerned about pre-checking versus post-checking. I just know that there is a loop in this logic. I'll be doing okay so far. Okay, so I'm not really writing code right away. Okay, I'm thinking this through just by looking at the most obvious parts. Okay, and I try to refine the algorithm as I go. Okay, so basically what I know at this point is there is a loop. Okay, now just knowing there's a loop is very important, because whenever there is a loop, there's a condition you have to consider. What kind of condition are we talking about? A while loop has a condition, a for loop has a condition, a do while loop has a condition as well. What does that condition do?
While the dividend is way greater than or equal to the divisor.
But that's the actual answer to this assignment. But in general, what is the job of the condition of a loop? It determines something, right? It determines whether I should stay in the loop or whether I should get out of the loop. Okay? So I have to ask myself that question. Okay? So we know there's a loop, and you can either think in the exit condition, or you can think in terms of stay in loop condition. Okay? Choose one. Okay? Whichever one seems to make more sense to you, use that one. Okay? Because these two are quote unquote equivalent. Okay? You can use one to derive the other one. All right. When you look at my example here, okay, what do you think is important as a condition? You are basically looking at true, 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 false. Okay? So what am I comparing in that case? Go ahead.
The dividend and the divisor.
The dividend and the divisor. Okay, so let's go ahead and just write it down. Okay, so I'm going to do something that is not even in C or C++. I'm just saying that there's some kind of a loop here, and whatever is between loop and end loop is the content of the loop. I don't even know what it is supposed to be, but I can tell you one thing. Okay, exit when dividend is less than divisor. Okay, does that make sense? Based on my example by hand, This is what I can observe and go like, well, it seems like I have to do something repetitively, but I stop when the dividend is less than the divisor. Okay? Now this is important because if the condition of the loop involves dividend and divisor, that means in the loop itself, at least one of these two will be touched. Why? What happens if the loop itself does not change dividend or divisor? What would happen to that loop? If this is false to begin with, it will stay false the entire time. It becomes an infinite loop. So that means just by identifying the condition of a loop, I have just identified candidates of stuff that needs to be changed in the loop. Does that make sense to you? Okay? All right. Let's see which one I can change. Can I change the divisor? In other words, can I change the nature of the question? Somebody's asking me, what is the quotient and the remainder of 25 divided by 7? And I go like, well, let me change the divisor and I'll give you the answer. Can I do that? I cannot, because that really is the question itself. So the only one that is left is dividend. That's the only thing I can change. Okay. So now we can go back here and say, well, dividend needs to be changed somehow in the loop. Okay. And how do we change dividend? If you look at the example here, 25 became 18, 18 became 11, 11 became 4. So how did we change it?
Subtracting the divisor.
Okay, that's very good. So there are two ways to do this. Without using C-specific syntax, this is the usual way of how people do it. Dividend equals dividend minus divisor, okay? Which is a pretty safe way of doing things because all programming languages support this, okay? On the other hand, if you are familiar with C and C++ and you don't like to type, okay, you can do something like this. It means exactly the same thing. Okay? This is called a compound assignment operator. Okay? It will do the same thing as what I showed a little bit earlier, except you don't have to type as much. Are there any questions about this part, the compound assignment operator, as opposed to using a regular assignment and a regular subtraction on the other side? Okay. Well, that's good. Okay. So at this point, my loop will exit eventually, and the dividend will eventually become less than the divisor. Okay. But the answer is not here yet. I didn't do a single thing about quotient. I did not do a single thing about remainder. Okay. So I need to figure out, how would those things, fit into this whole thing. What do you think? Go ahead.
Remainder equals to dividend. The minus equals divisor.
Okay.
And then I basically just put the quotient as plus quotient.
Okay. Yeah. Well, you're absolutely right, because quotient does increase every single time with each iteration. So that means that code has to go into the body of the loop. So quotient equals quotient plus 1 is in the loop. Okay, plus quotient is a much faster way to do the same thing, but this will do as well. Okay, so this is one way to do it. Or if you want to, you can do a plus quotient. Or if you want to, you can also do a quotient plus equal 1. They all do exactly the same thing. Okay, as far as the effect of the code is concerned, they make no difference. Choose one of the three. Are there any questions at this point about tracking the quotient? But quotient itself is uninitialized. Okay, it is just a local variable. So should I initialize at the beginning of the loop here? What would happen if I initialize quotient at the beginning of each iteration? Then it will
Put it to 0.
it will reset it back to 0 and then increment to 1, reset back to 0 and increment to 1, right? That's not how I want to do it. So what would be a good place to put the initialization of quotient relative to the loop itself? Before the loop, right before. That would be a good way to do it. Okay, so we put it before the loop. So we say quotient equals to 0 to reset it all the way back to 0. There's only the remainder left, okay? When you look at this example here, 4 eventually is the remainder. Okay? So which variable is tracking 25, 18, 11, and 4? According to the code that I have at this point, which variable is tracking those values? 25, 18, 11, and 4. The dividend, right? So that means when the loop exits, dividend is the remainder. So I can now say, there are several ways to do it, but this is one way to do it. Remainder is whatever is left in dividend. The other way to do this is to say remainder equals dividend at the beginning, and then throughout this loop, just make use of remainder and forget about dividend altogether. So there are several ways to do that. Okay, I still have one more important question. There is no such thing called loop and loop in C or C++. We have while, we have do while, and we have for. So the big question is, should I check the condition first, or should I check the condition after at least one iteration of the loop?
You should check the condition before.
And why is that? That's the correct answer, but why?
Because if you check it before, then it won't go through a process that it can't actually compute.
You're absolutely right. So if I give you a dividend of 5 and a divisor of 7, 5 divided by 7 has a quotient of 0 and a remainder of 5, right? So if you check the condition first, it would give you the right result right away. But if you check the condition after, it will give you the wrong result.
Yeah, so like for my condition, I just did as long as the dividend is greater than or equal to the divisor.
So you have a while at the beginning here. So you say basically while dividend is greater than or equal to divisor, and because there are two statements in between, we have to use an open curly brace to turn this into a compound statement or block statement. And I'm going to just choose one of the two representations, and that's basically the loop. This is the statement after the loop, and this is the program. This is the code that has to fit between the two labels. Are we doing okay so far with this? Okay, yeah, go ahead.
Yeah, would it matter if the remainder was inside of the loop or not?
Well, that's a good question. So the question is, would it matter if we do this or the other way around? The answer is you have to do it after, because if you do something like this, that means remainder is going to be uninitialized if I give you 5 divided by 7. Is that making any sense?
No.
Okay, if I give you 5 as dividend and 7 as divisor, then you won't get into the loop even once, and remainder will remain uninitialized the whole time.
So can you solve that by initializing remainder?
Yes, you can, but then you will have extra operations that really does not need to happen.
But does that matter in terms of?
Well, if it gets the job done, I'm not going to ding you, or you can do this first, right? Okay, and then do every single iteration. Then it will still be correct. It's just that you're doing something that does not need to be done.
Okay.
But in this class, I only care about correctness. You can basically take the scenic route as long as the answer is still correct. It will still be okay.
Because like I was saying, what I did is I basically put remainder equals right before you put dividend minus divisor.
Okay. Well, if I did something like this, I might as well just change everything to remainder inside. Right?
No.
Why not?
Because dividend is the one that's initialized, not remainder.
But I just made remainder the same as dividend right before the loop. I have this line here.
I mean, yeah, you did that, yeah. I wasn't thinking about that.
In other words, there are multiple solutions to this particular homework assignment. Okay? I can do this with a while loop. I can do this with a for loop as well. Okay? Because a for loop is a while loop, except it does certain things automatically. Yep.
Is there an until?
No, there's no until. There's do while,
Okay.
which is the opposite of until.
Okay.
Yep. Alrighty. So given this is the code and it has a syntax issue here, I'm going to keep the syntax problem here, okay? So what I'll do next is I'm going to say, well, I think I got most of the code done, so I'm going to type it in. Okay, so here I'm going to type in the code. I need to display both at the same time. Well, I can always do this. It doesn't look very good this way, but it will still work. So I'm going to just type in the code here. I will say quotient equals 0. Yes, I know there is a syntax issue, but I will leave it here so I can show you what to do about that. Okay. While remainder is greater than or equal to divisor, let's do the following. Remainder is decreased by the same amount as divisor, and we have quotient equals to quotient plus 1, and I'm done. Okay, I'm 100% sure 90% of this class can identify and go like, well, this program is not going to compile. Okay, well, that's intentional. I don't want it to compile because I want to show you what happens when I try to compile this. Okay, so let's go ahead and compile this program. So g++-c-warn all, that's G, okay, main.cpp, and it gave me a bunch of stuff, okay. The warnings, we have seen it already in class, and I told you guys, oh, it's okay to have these warnings because you don't have any go-to statements to go to those particular labels. That's cool. What about the errors? Whenever you have an error, the program actually did not compile. If the program did not compile, it won't give you an object code file to link, and without the object code file to link, you cannot run the program. In other words, if you see an error, you have to fix those. Warnings, you don't have to fix, but errors, you do. Okay? So now it's telling me 2 error messages. The first one is kind of self-explanatory. It tells me on line 16, it is expecting a semicolon before remainder. Let's fix that one first, okay? Now, I usually just fix one problem at a time because after fixing one problem, it might fix the second one. In this case, that is not the case, but it doesn't really hurt to just fix one problem at a time, okay? So after fixing the first problem, the second problem is still here because it's a whole different problem. It's not because of the first error. Okay, but I still have one error. There's a reason why error is highlighted in red. Okay, it's telling you cannot ignore this. Okay, so you have to fix it. So now it's telling me it's expecting a end curly brace at end of input, which means at the end of the file. What that is telling me is the program has a missing end curly brace. Okay, so what do you do with a missing end curly brace? How do you know which one is missing? Well, that depends a lot on whether you do the indentations correctly, because in this case, my indentation clearly indicates that the open curly brace is missing an end. Okay. On the other hand, if the program does not have the correct indentation, it makes it really hard to find where that end curly brace is supposed to go. Okay. So that part depends a lot on how you structure your code. Okay, now that the program is all done, okay, I fixed the second error, hopefully. The compiling is okay. It only gave me the 2 warning messages that are meant to be, okay? So now I can finally link the program, g++-o, and this is called main.o, and now I can gdb the program, okay? So I can go into the debugger and put breakpoints into main : start here, and put a breakpoint at I think check here or stop here. I can't remember. Yep, check here is correct. Okay, so now I can start to debug the program. So I go run. At the first breakpoint, I'm gonna change the problem itself. So in this case, I'm gonna do a set var dividend equals to 25, set var divisor equals to 7. Now, if I am not confident about the program being correct, I would single step at this point. Okay, I would just single step, make sure that it gets into the loop when it's supposed to, it gets out of the loop when it needs to. When it updates the variables, I would print the values of the variables just to make sure that every step along the way the program is behaving correctly. Okay. Okay. Yep.
Do you have to set all of the variables?
Just two.
But
Yeah,
those
these.
are the only two that are actually like have initialized values.
Correct.
So
But
you
the
have-
initialized values are just one particular test case. So I'm giving myself a different test case at this
Of
point.
course. But I have this problem when I'm trying to use GDB that says no symbol dividend in correct context.
You have to run the program first. You have to one, set breakpoints. Two, run the program. When you have stopped at a breakpoint, then you can examine or change the variables.
Okay.
Because until you run the program, these are all local variables, right? Does anyone remember what I talked about last time on Monday that is related to this particular issue?
Subroutines.
Subroutines. Main is a subroutine, right? And all of these variables are local variables. And do local variables exist before the subroutine is called?
Yes.
No.
No?
No. That was the whole point on Monday, okay? So local variables do not even exist before the subroutine is called because they are allocated and created on the fly when a subroutine is called. So that means before you run the program, main is not getting called, so none of the variables of main even exist at that point. And that's why you cannot examine or change those variables.
Okay, because I just had a hard time kind of like testing out multiple cases for my program, so I was just so
Yeah, we worked on a few test scripts last time as well.
So was that on Monday?
Yep, that was on Monday.
Okay.
Yep, I showed you guys how to make your own text file, which is kind of like a test script, and you can make it fancy, you can make it kind of simplistic, but the whole point is you can use GDB main and then a less than symbol and then the text file, so that you can basically rerun the same test cases every single time as you make changes to the program. So this way you can double check your program to make sure it's correct for all the test cases that you have come up. All right. So are there any questions at this point about the process, the program itself? Okay. So I'm fairly confident this code is going to work. Okay. So I'm going to continue the execution until it gets to the end label. So at that time, I will print the answer, and part of the answer is in Quotient. And Quotient has 3, which is correct, and part of it is in remainder, and it has 4, which is also correct. So the program works in this particular test case, okay? Just because it works in one test case does not mean the algorithm is correct, okay? So you will have to find out, what test cases to use to test your program, okay? There are tricky ones, there are not so tricky ones, and you kind of have to come up with your own test cases to test your program. Are there any questions about this whole process of writing your code? Now, I know this is hard, okay? The learning curve comes from not only having to derive the algorithm itself, but you're also dealing with a tool, okay? You're dealing with G++ and GDB, those tools. You're dealing with potentially a new editor for those of you who want to learn how to use VI. You're dealing with the syntax of C++, okay? This is not pseudocode where, well, if my professor can read this, it's good, okay? No, I can read more than what a compiler can, but if the compiler complains about it, your program is not going to compile. So that's why there's definitely a steep learning curve to all of this, because it's a combination of all of those factors: tools, the language itself, and the logic of the program. Which part bothers you the most? The tool, the language, or the logic?
I think
The logic, okay? Some people say the logic, the tool. Does anyone want to say the tool? Okay, the tool is just a matter of using it more often, using it more. The more you use it, the more familiar you will be with the tool. Okay, so it's kind of like driving a stick shift. Okay, the more you do it, it becomes second nature at some point. Okay, but knowing how to drive a stick shift without even thinking about it doesn't mean you can navigate to a new destination without referring to your GPS. That's the logic part. Okay. So all of this stuff, it just takes time. Okay, trust me, it really just takes time to get used to it. You have to start early, because your brain is going to work on the problem even when you are not thinking about the problem, but you have to get it started first, okay? One analogy that I gave to many of my classes is your brain is like a slow cooker, okay? So you have to put in all the ingredients, okay? The ingredients would include paying attention in class, reading the material, okay? Reading the homework assignment, and just put it into the pot, okay? So you have to start early, because if your brain is a slow cooker, it will keep cooking when you are not thinking about it. But it needs time, okay? That is the most essential element, is it needs time. So you have to start early so that your brain can start to cook, can try to combine the ingredients. And occasionally you just check the pot and go like, well, let's see what I can do about it. But your brain does work on problems when you're not thinking about it. Are there any questions about the divide homework assignment? Now this is still, I would still consider this an early homework assignment, so the point value is still not too bad, okay? So if you miss this entirely, I still would not worry too much about it, although, it will be a good idea to think of, how can I get started, earlier next time, or, what should I do, about, working on my homework assignment next time, which is today, because we have a new homework assignment. This one is not going to be a long homework assignment. I hate long and tedious homework assignments myself, so I would never give something like that to you guys. This is called bit counter as a homework assignment. Bit counter, okay, has a file that you have to download, kind of the same setup as the previous homework assignment. So I'll do exactly that to show you what it is. So I'm going to save it into my temp folder and switch to my terminal and just uncompress XZVF. This is called bit counter. Change the folder and look at main, because main itself actually explains what you have to do. All right, so this is the description. This time we have, main itself is not something that you have to do a single thing about. Okay, this is main. All main is going to do is to declare two local variables. One is called n, the other one is called bits. N is initialized to a value, but you can see that the initialization of n is before the start here label for the same purpose of the labels that in your current, the homework assignment that was due today. Okay, so this way I can stop before your code and stop again after your code, so I can check whether your code is doing it correctly or not. Okay. After the label start here, we have bits equals to bit counter in parentheses n. In other words, I'm calling bit counter as a function, using n as a parameter, as an argument. Bit counter would do something, and what it's supposed to do is described up there. I will explain that later. Whatever value it returns, I will store it back into bits. This is only for grading purposes, so I can actually see the result that it returns in a variable. Are there any questions about main? You don't need to do a single thing to change main for this particular program. Now, it doesn't mean that you cannot, okay? If you decide to do something to help you debug the program, you can do whatever changes you want, but you have to undo those changes before you turn in your homework assignment. That's basically it. Okay? So your main, yeah, go ahead.
I was just looking at it. So you don't want the width of the number, you just want the number of used bits, like the number of ones.
I want the number of ones in the number.
Okay, yeah.
Okay? So now, if I go back to the description of bit counter, this is the explanation of what bit counter is supposed to do. In the following provided code is a placeholder, okay, which is referring to the 0 here, okay? So your job is to replace that 0 with an expression. Now, I'm not saying anything about the complexity of the expression itself, okay? It can be a very simple expression, can be a really long expression with 20 operators in it, okay? So you will have to decide how to structure that particular expression, but you are only allowed to change that 0 into a single expression, okay? Replace the 0 with another expression. The job is to change the value returned by the return statement, change the 0, so the bit counter as a function returns the number of bits that are ones in parameter x. This is parameter x here, okay? For example, I'll give you some examples here. If x is 33 in decimal, then the binary representation of 33 is 1 followed by 4 zeros and then another 1. So the function should return a value of 2 because there are 2 bits with a value of 1 in 33. Okay? Another example, if x is 0, the binary representation should be all zeros, right? So it should return to 0 because there are no bits of 1 in 0 as a base 2 number. Are we doing okay so far with what the function is supposed to do? Not so much how to do it, but what it is supposed to do. No questions about that? Okay. Your code cannot introduce any new statements, so you cannot have a loop, cannot have a conditional statement, or anything like that. However, you can use any combinations of any operator to replace the 0. The only function you can call is bit counter itself. So that is a big clue already of how you should start to think about this problem. Yep. Question? No. Okay. All right. So getting back to the homework assignment description here, I'm giving you more examples. Bit counter with a 5 will return a 2 because 5 is 101 in base 2, so there are 2 bits with a value of 1. 7 is 0, 1, 1, 1, so there are 3 bits with a value of 1. 0 itself has no bit having a value of 1, and that's why it returns a 0. 32 is 1 followed by 5 zeros, so it will also give you a value of 1 because there's only 1 bit with a value of 1. Are we doing okay so far with this code here, or what the program is supposed to do? So this sounds like a pretty simple homework assignment because all you are going to do is to come up with one single expression that will do all of this stuff here. But the same restriction that makes it look like an easy problem makes it hard as well because you cannot use a loop. You cannot use a conditional statement. So what are you going to do? Or how are you going to do this? Recursion, very good. Okay, so recursion is going to be one of the things because it states right here, this assignment may involve the following. Okay, when I say may involve, it means in this context, it will involve the following concepts. It will involve recursion. This one is an either or, okay? Well, or you can do a combination of the two, but I would just pick one if I were you. You can use bitwise operators to solve this problem. Or you can use your kind of more conventional division-related operators to solve the problem. So it's entirely up to you which one you want to use, just pick one. You also will need to use a ternary operator because you will have to say, in this case, I'm done. In this case, I'm not done. We have something else to do. Okay? Yep. Sorry? No, it is not a statement. It's an operator. It is used in an expression. So technically, it is not a statement. It does give you the ability of branching, though. Okay? All right. So instead of leaving you guys completely in the dark, okay, I'll give you some examples by hand. Okay, so this is how I would look at this, by hand and just kind of go, okay, if I were to count the number of bits in the number, how would I do that? So let's see. Let's go back to the text editor here. And I'm going to do this by hand. All right. Let's try a particular number. I don't know. 237 sounds like a good number. Okay, so we'll start with this one. So you look at 237 and you say, well, does it have at least one bit that has a value of 1? Okay, and why do you think that is the case? Okay, go ahead. Go ahead.
It's larger than 1. It's larger than 1.
Say that again?
It's larger than 1.
It's larger than 0.
0.
Okay. Well, it's larger than 0. That's good. Okay. But there's a little bit more than that. Okay. Is this number odd or even? Odd, okay, and all odd number in base 2 has a 1 as the least significant bit. Okay, as a least significant bit, it's going to have that 1. Okay, so I know it has a 1 because it's an odd number. Okay, so you say, oh, 237 is odd. It's LSB, least significant bit in this case. The lowercase b is intentional. Uppercase b usually refers to byte. Lowercase b refers to bit. So this is the least significant bit is 1. Okay? Okay, count that 1. Okay. But what about the rest of the number? What about 236? Well, you know what? I'm lazy. My only thing is to look at the least significant bit. So who's going to take care of the other bits? Recursion. So the next invocation will take care of the other bits. What other bits are we talking about? Not 236, but 236 divided by 2. Because the next person is also going to say, I'm lazy, I'm only going to look at the least significant bit. But I don't want the next person to look at the same least significant bit that I have handled already. So I want the next person to handle a number where to that person is the least significant bit, but to me is the second least significant bit. Are we doing okay so far with that analogy? So far so good? Okay, I'll give you, one complete analogy. So let's start with, let's do with 5, okay? 5 is easy because I just need like a few people to do it, okay? So I'm the first call to bit counter, okay? So I'm the one who has, the parameter x being 5. And I'm lazy, right? Okay, I look at the number and go like, that's not 0, so I think I have to do something about it, okay? Because if it is 0, you know what? I can answer the question right away and say, nope, there are no bits of 1 in this number. But since it's not, well, I guess I have to work. So what do? I look at the least significant bit and go like, well, is this number odd? 5 is odd, right? So I go like, well, I guess there's at least 1 bit. I count at 1. And then what do? I go like, well, I'm not going to be responsible for all the other bits, okay? I'll leave it up to you to handle the second least significant bit. All right? But I don't want you to process 4 because 4 has the least significant bit already taken care of. I already counted that bit. So what do I want to do? What are you going to do? What number am I going to pass to you? So 5, I took care of the least significant bit already. So how do I get the second least significant bit to become the least significant bit? There are 2 ways to do it. You can do a bitwise shift or you can do a divide, okay? They will both get the trick done. So what I'm going to give you is 2. Okay? So I will say, hey, tell me how many bits how many bits of 1 2 has, and I'll add your number to mine to become my answer. Is that okay? So what are you going to do? You're going to do exactly the same thing that I did. You look at 2 and go like, is that 0? Because if it's 0, you're all done. Well, 2 is not 0, is it? So what do? You look at 2 and say, is it an odd number? Is 2 an odd number? 2 is not an odd number. So the least significant bit that you are responsible to process is a 0. Okay? But the number itself is not 0, so you know there are other bits of 1 for somebody else to handle. Okay, so what do? You basically say, okay, I took care of the least significant bit of 0 in your case already, but somebody else will have to handle the rest of the bits. How do you turn the second least significant bit into the next person's least significant bit? Shift operation or divide, right? So what do you give to the next person? What is 2 divided by 1? 2, no, I take it back. What is 2 divided by 2? Okay, because division by 1 is not useful. 2 divided by 2, or shifting by 1 position, gives you a 1. So you pass it to the next person along, so you get the 1 to process. And you're going to do the same thing as everybody else. You say, well, am I given an easy question? Like, is that 0? No. know is a 1, so you cannot just say, oh, it's all 0. So it's 1 an odd number. 1 is an odd number. So what do? You say, well, I know there's at least 1 bit of 1 given the number that I'm supposed to process. And then what you're going to do is to pass it along to the next person, the rest of the number. Okay? So you took care of the 1. What is 1 divided by 2? The quotient. 0. 1 divided by 2 as a quotient is 0. So you pass the 0 to the next person. Okay? That person is the lucky guy because he says, oh, somebody gave me a 0 and asked me to count the number of 1s in 0. That's 0, obviously. So you answer right away and say, hey, it's 0. So you add what he has to your number, which is 1, and then you say, that's my answer to this guy. Okay? So you answer 1 to this guy, and then he says, okay, we have 1 bit of 1 from the person that I defer to, and I only count 0 because you have at least significant bit of 0 to begin with. And then you pass 1 back to me, right? And I go like, okay, the rest of the bits has 1 bit of value of 1. I found 1 myself, so there are 2 bits of 1, and I answered that one directly back to me. Okay, I'm not sure whether this is working or not. Is that working? Sort of? Maybe not? Okay. So the idea is this. This is the idea. You have a number. So let's pick one that's bigger. Let's pick 13 as a number. Okay, 13 in binary is 1101 in base 2. Okay, so in 1101, the first invocation, every invocation only pays attention to the least significant bit. Okay. So the first invocation says, okay, there's 1 bit of 1, okay? But what about the rest of the number? Well, I'll defer that to somebody else. Well, the next person is going to get the other bits, which will be 110, okay? Because you don't want the next person to process the same number as you do, okay? So the next person will handle the rest of the bits. So it'll be 110. 110, the next person will only take a look at the least significant bit, which is a 0. So there's nothing here. And then the next one is going to have 1, 1. The least significant bit is a 1 in this case, so that person will count 1. And then the last person, second last person, will have a 1. And that bit, the least significant bit is a 1, so count 1. And then the rest, you have to call one more time because the last person will get a number of 0 to process. That person will basically say, since the entire number is 0, we are done. Okay, I don't need to defer this to anybody else because I know for sure there are no bits of 1 in this number anymore. Okay, so that person will answer a 0. That 0 will be added to this 1 here. That will give us a value of 1, right? That 1 will get passed back to here. So we get a value of 2. That value of 2 will be passed back to here, and that will give us 2 here. And that value of 2 will get back to here. Whoops, I just overwrote this. To here, and that will give us a value of 3. So the final answer is 3 in this case. Are there any questions about this? No questions, sort of? Let's take a look at factorial again. Okay, I know some of you are kind of sick and tired of factorial, but it's kind of important. Yep.
I have a question about functions in general.
Okay, go ahead.
If I wanted to return multiple values, how would I do that?
You have to return the structure instead. So we haven't talked about structures yet. So at this point, we do not have a mechanism to return multiple values. You have to use pass by reference to do that.
Okay, because I've just been trying to read those pages of something called tuple.
C does not have the concept of tuples.
Really?
Nope. Does not have that concept, so it cannot be done. Okay, so what we'll do today, what we'll do next is to go back and take a look at factorial. Okay, so I'm hoping that most of you still remember factorial. We'll go back to here, vim factorial.cpp. Factorial is something that we have looked at already. But last time when we looked at this, we had a control structure because I used a conditional statement to do this. Okay, so I'll just go with the conditional statement first, and then we'll convert it into a ternary operator. So that might give you some idea of how to deal with your homework assignment. So with the conditional statement, remember what I said, I always give you the skeletal structure first, and then go back to fill in all this stuff here. With factorial, by definition, if n is less than or equal to 0, then the factorial of n is 1. But if n is greater than 0, well, this is the actual definition. It will return n times the factorial of n minus 1. Okay. Do you guys have some recollection of this? Okay, very good. So in the main program, it's not too hard to get this thing to work entirely as a program. So we'll have a variable n and f here. And just like in the program that we're dealing with, we say n equals to 3, f equals to the factorial of n, and return 0. So the structure of the program is the same as your homework assignment. Okay, let's turn on the line numbers, and I'll explain the significance of the conditional statement. In this conditional statement, there are two branches. Okay, there's the then branch and there's the else branch. How you want to structure your branch, like which one does the recursion, does not really matter. Okay, so in this case, it's the then branch that stops the recursion. Because when you look at line 5, does line 5 call factorial? Does line 5 call anything? Nope, line 5 just says return a constant of 1. So that means that is the stop condition of recursion. When n is less than or equal to 0, in this particular case, you can stop the recursion, you can stop deferring the answer and just say, oh, I know the answer right away. I don't need to ask anybody else. The answer is 1. And you just go back. Are we doing okay so far with that? Okay? That is called the base case of recursion. This is when you stop the recursion. Line 9 is important because it is a step of recursion. In other words, when n is not less than or equal to 0, then the factorial by definition is n times the factorial of n minus 1. And that's when you say, well, I can handle a part of the problem. I can deal with the multiplication, but somebody else, please find out what is the value of the factorial of n minus 1. Who is going to figure out the factorial of n minus 1? The same subroutine, but a different and a new invocation. Are we doing okay so far with that concept? A new invocation will take care of the factorial of n minus 1 and come back with an answer. When it comes back with the answer of the factorial of n minus 1, I would take that value, multiply n to it, and that becomes my answer to whoever is calling me. Are we doing okay so far with that concept? So it all has to do with breaking a problem into a smaller problem that has exactly the same nature as the original problem, but it's one step smaller. And at some point, it has to stop. It has to basically go to a problem that has a trivial answer, and you do not need to do recursion to find out what the answer is. Is that okay so far? Are there any questions about recursion in the case of factorial? No questions about this one? Okay. All right. If there are no questions about this, then it's time to look at the other way to do factorial. Well, before that, we'll double check and make sure the program does compile. Okay. Because I hate to give you something that does not compile and has syntax problems. And so it does compile. I'm fairly sure the code does work. So now the question is, well, since TAC did not specify explicitly we cannot use any control structure, how do we solve this problem? Well, we have the ternary operator, which has the same effect as branching. Okay, so what we're going to do is I'll give you the second version of this. So the second factorial is the same as the first one, functionally speaking, but it will do it in a slightly different way. It has one single return statement. Okay. we already know it has a ternary operator, because a ternary operator is the only way in an expression to do the same thing as branching. What do you think is going to be the condition of this ternary operator? Would it have any relationship to the condition of the conditional statement? It's the same thing, okay? Because we are still determining whether to do recursion or not using the same condition. So to the ternary operator, we're going to use the same condition, okay? Then we have to specify the then value of this ternary operator. What is the then value of this ternary operator? It's 1, okay? If n is less than or equal to 0, the answer is 1, not 42. You guys are not getting it.
I got you.
Okay, very good. What about the else part? What if n is not less than or equal to 0? What should I be returning? N times the factorial of n minus 1. So just to make sure that we know, how the operators, nest within each other, I'll just put in extra parentheses. It's not needed, but it does help the readability of this program. So when you look at the first version of Factorial from line 1 to line 11, it really is just a longer, more spelled out version of the second one. And the second one, which is from line 13 to line 16, is the shorter version of Factorial, but it gets the same job done. Okay? So are you guys getting some idea of how to proceed with this? So you kind of have to look at this code here and combine it with the discussion that we had earlier about, is this number odd? If it is, I can count at least 1. The rest of the number, I'll pass it on to somebody else to process. Okay, so you will have to figure out, what are you returning? How do you combine the result of the next person with your result? Okay? And what is the number that the next person has to process? How do you break the big problem into just one step smaller for the next person? That really is the key. And it has something to do with shifting or division. And something has to do with modding. Okay, so there are several ways to do this. Solve this problem. It's up to you guys to decide which way to go. Okay. So this is your next homework assignment. I would say get started with this one early, okay? Because this one has less problem with syntax, but it has more to do with recursion, okay? So you guys kind of have to know how to track recursion, okay? Are there any questions? No questions? Okay, I'll just give you one extra clue. Okay, I think you guys know this one already. If I'm counting bits, okay, counting bits of 1, okay, what is the trivial question that I can answer right away? I don't need to ask anybody else. Come on, you guys know the answer. Which number is trivial to process that I can answer right away? 1 is not. 0, okay? If somebody asks me and say, hey, Tack, how many bits of 1 do we have in 0? Well, 0 has 0 ones, okay? I can answer right away. So now you have to think about, where do I put that condition in your homework assignment? Because that becomes an important thing to ask, because it does branch in two directions. Because if it is, there's an easy answer. If it's not, the answer is not as easy. Okay. And then the next question is, how do I break a bigger problem into a smaller problem? If I'm given a number of 4, okay, that's what I'm supposed to process. Which bit am I supposed to look at in 4 as a binary number? The least significant bit, right? Because I only need to know whether a number is odd or not. Is 4 an odd number? 4 is not an odd number. So as far as I'm concerned, I can find 0 bits of 1 because I'm only looking at 1 bit position. But I know the number has at least 1 bit of 1 because it is not 0. So what do? I'm going to call the subroutine again. When I call the subroutine again, what should I ask the next person to do? What is the number the next person has to process? Should it be 4? No. What should it be? 2, exactly. So that person will say, oh, this is an odd number 2. I know that the bit I'm supposed to look at is a 0. So as far as I'm concerned, I will count a 0. But the number itself is non-zero, so I know there's at least one bit of 1 in the number. So we'll pass along to the next person who's going to get 1 to process. So that person will look at 1 and say, hey, 1 is an odd number. There is exactly 1 bit of 1 in 1. And the rest of the number, I'll let the next person to process. So the next person will process a 0, which is a trivial answer of a 0, and then things get back, eventually, like that. Are there any questions about this whole thing? I'm trying to use different ways to explain the same thing, so I just want to make sure that you guys know how to approach the problem. No questions? All right. If there are no questions, I will move forward and leave it to you guys to work on this homework assignment. I would definitely work on it over the weekend because Monday is the last day that you guys can ask questions about this particular homework. So if you're stuck, okay, that would be a good way to ask questions on Monday. This is a new reading material. It is actually new this semester. It's about by value versus by reference. Okay, so this is a new reading material. You really should go through this, but I can give you a general idea of what it is about. Okay, and I'll give you basically sample code, in this class, and so you can actually go through a GDB session, so you can see what is passing by value and what is passing by reference, and how do they look? How do they look from the perspective of GDB? Okay, I call this program params. Okay. All right. So this is what I will do is I want to write a subroutine that can change a parameter to 0. Okay, so I would call this set 0. Okay, and it's going to be an integer. I want to reset an integer to 0, so I would call that parameter x, and I say x equal to 0 here, and I'll call this set 0,1. I'll call this set 0,2 because it is a slightly different way of doing it with an ampersand. Okay, there we go. So now we have 2 subroutines that look almost identical, except with the second one, we have an ampersand in front of x. Okay, that is called passing by reference. Without the ampersand, it's called passing by value. Okay, so we want to find out, how are these 2 different? We have main. Let's make a new variable here. Let's call that n. Okay, they don't have to be the same. N equals to 23. I explicitly initialize n to 23, which is not 0. I call the first subroutine set 0,1 with n, and then I call the second subroutine set 0,2 with n as a parameter, and return a 0. Okay. So this is a sample program. The only purpose of this program is to illustrate the differences between passing by value as opposed to passing by reference. Okay. So we'll take a look at this program. The explanation is in the reading material, but I want to show you interactively, how these 2 subroutines will behave differently. So G++-1 all -G-C params.cpp and G++-O params.o GDB params. There we go. All right. When you list a program, it will only list up to 10 or 12 lines. Well, it only actually lists only 10 lines, so you can press the Enter key or just L again to list the rest of the program. In this case, I'm not so interested in line 17 because the behavior of line 17 is pretty predictable. Line 18 is the first place I'm going to stop. Okay. Run the program, and if I print n, what do you think it should print? I'm on line 18. I just executed line 17. 23, right? This is hardly exciting, okay? Because it's just an assignment statement that happened before this, okay? So now I single step, okay? I single step into set 0, 1, and you can see that GDB tells me, oh, parameter x has a value of 23. Is that surprising to you? No, but this is passed by value. Now, a parameter that is passed by value is basically the same thing as a local variable, except the initial value of this x is controlled or determined by the caller. The caller said, hey, x should start with a value of 23. Okay, fine, x will start with a value of 23. Is that okay so far? So nothing too surprising at this point, right? Single step. And if I say print x at this point, what do you think x is going to have as a value? Come on, you guys can do this. 0, exactly. Because I just put a 0 into it. Okay, here's the question. What about n of main? Well, how do you check? Okay, the first thing is, how do you check variable n of main at this point? Well, you cannot say print n because n is not in set 0, 1, and therefore there's no visibility of variable n. Do you guys still remember backtrace, BT? Okay, so we do a BT. Main is frame number 1. So we say frame 1 to switch the current context to main. And then we can say, oh, show me all the local variables. Info locals will show all the local variables. Okay, so let's stop for the time being. N is still 23, but x got 0. What is that telling you? Those two are not related. The only time there's a relationship between the two is we use the value of n to determine the initialization of x. After that, parameter x of set 0, 1 has nothing, absolutely nothing to do with local variable n of main. Is that part okay? This is called passing by value. So once you set the initial value of a parameter, the parameter is decoupled completely. It has nothing to do with what you used to initialize it anymore. Is that okay so far? Okay. So we'll switch back to frame 0 so that we can continue to single step the program. So now we are back to main. Going back to main, if I say print n, what do you think it should print? Did I change n? No, I did not change n. Setting x as a parameter to 0 did not do a single thing to n because the parameter was passed by value. Okay? So print n gives me 23. Nothing happened to n. I single step again. This time I'll be single stepping on line 19. I'll be calling set 0 to the second version. And right away, something is different. Okay? If you compare the first call, which is set 0, this line here, versus this line here, what do you see that is a little bit different? Okay, let me just point out again which two lines we're comparing. We're comparing this line as opposed to this line here. What do you see that is a little bit different?
You're setting x to the value stored in relocation.
Exactly. So x as a parameter does not have 23. X is now a reference to a location or reference to a variable that actually has a value of 23. Okay. In other words, x as a parameter does not have a value. It is simply an alias of somebody else, of another person. It's a portal, okay? It's basically a portal to another variable. Whatever you do to x is being done to the variable at this location. And guess which variable is at that location? Local variable n of main. Is that concept okay so far? Because I know this is a little bit abstract, but in cisp360 they should have at least touched on this concept of passing by reference. Well, let's go ahead and do this in a single step. Okay, I'm single stepping line 9, setting x to 0. Okay, So now we want to print x. Okay, x being 0 is perfectly normal, but see what happens when I say print x? It doesn't just say x equal to 0, it gives me some gibberish of at 0x bff f3 f4 is 0, because it is emphasizing that x itself does not store a value. It is just a reference to another variable, and the variable it is referring to has a value of 0. So what is your suspicion? What do you think is the current value of n at this point? Should be a 0, right? How do we check that? So we switch frame to frame 1, which is main. And now we say, well, there are several ways to do it. You can just say print n, or if you want to know the values of all the local variables, you can just say info locals. And n does have a value of 0 at this point. That's because x as a parameter is passed by reference. Okay. Switching back to frame 0, we can now continue execution. Yes, go ahead.
And when you pass it by value, it's also 0. Right?
Say again?
When you're passing it by value.
N did not change to 0.
Oh.
N remained 23 the entire time when set 0, 1 executed. But this time, it got changed to 0. So when I single step this and get back to main, N changed to 0, because we changed it to 0 while we were in the subroutine. I can give you one analogy that many of you can, well, I take it back, but I will give you that analogy anyway. Because it relies on people knowing how the library works, how to check out books, okay? How many people check out books from the library these days anymore? Oh, okay, so a few people still do. Okay, good. All right. So passing by value is like going to the library to check out a book. Well, let me rephrase that. Okay, a subroutine is like a person who's supposed to work on something. Okay, passing by value means somebody have a book, and they make an entire photocopy of the book, and you as a subroutine has a copy of the original book. That's what you use to do your work. Okay. So does anything happen to the original book? Nope, because all you're going to do is to work with the copy of the book. And what do you think happens to the copy of the book when the subroutine is all done? It goes away, right? You throw it into the garbage bin, the recycle bin, okay? All right, so how does this analogy work with passing by reference? If it's passing by reference, the subroutine is not given a copy of the book. The subroutine is given a call number, a little slip of paper, okay, a little post-it with a call number of the book to process. Okay, which is, and what do you do? What do you do with a call number? What is a call number? Oh man, you guys don't know how to use a library.
It's a reference to the location of the book.
Yep, a call number is basically a code, like all the computer science books are QA78 blah blah blah. Okay, so you use a call number. It's basically an address, okay, a GPS location of a book in the library. Okay, so you are given a call number instead of a copy of a book when it is passed by reference. So when the instruction says, oh, go to the table of contents of this book and count the number of entries of the table of contents, what are you going to do? Well, you cannot count the number of entries in the table of contents on the call number itself. The call number is nothing more than a little slip of paper with QA78 dot something on it. So what do you have to do? You have to go to the library, locate the actual book, and then use that to count the number of entries in the table of contents. What if the instruction says, go to the last page and just draw a happy face on it? So what do? You follow the call number, go to the library, check out the book, turn to the last page and draw a happy face on it. Don't do it, but that's what it would do. It would destroy, it would actually vandalize the actual book in the library. This is passing by reference. In passing by value, you can do whatever you want with the book because it is just a copy of the original book. So nothing is going to happen to the original copy in the library because you are given a photocopy. Is that okay so far? Okay. So try to remember, or if you don't like this analogy, think of one that you like and can remember. Are there any other questions? So the concept of passing by reference is in the reading material, by val versus by ref. Okay. If you already have exposure to this concept in cisp360, great. This is just a reinforcement. If you do not, and you have any questions, go ahead and ask. Okay, because this is a very important concept in C and C++. All right. Well, today's lecture is done. Start on the homework assignment early, okay? Because this one is a little bit on the tricky side, so you need to have time to get started early. All right.